So here's where we'll start. I think what might have happened is, yeah, I remember now. I did elimination as a way to solve this. And I was going to use this method of substitution, for review, but I think we ran out of time. So substitution, let me start from here. Again, this is just another way of actually solving a system of linear equations. And again, the whole idea is you want to somehow get one variable in terms of the other. So what I did, remember, was I used so basically you can get y in terms of x or x in terms of y. Here, what I actually did was I used the first equation to get x in terms of y. I mean, you could get y in terms of x. You can use the second equation. It really doesn't matter. But from the first equation, what I did was I get x in terms of y. So I subtract 2y from each side, as you can see. So we have 1 over 2 times x is 9 minus 2y, as you can see. And now we want to get x all alone. So I multiply both sides by 2. Or you could divide by a half. It's really the same thing, as you can see. Right? Because basically you want the coefficient of x here to be 1. And by multiplying both sides by 2, that's what's going to happen. See? I multiply. The 2's here go bye-bye. This 2 distributes, as you can see. So we have 2 times 9 minus 2 times 2y. These again are gone. That's all right. So we have x all alone on the left side here, right? On the right side, we have 18 minus 4y. That's what we have. 18 minus 4y. Okay. So now we know what x is in terms of y. Good. What do we do now? Well, as I have written here, we substitute it into the other equation. You don't want to substitute back into the first equation. That's not going to help you. You want to substitute into the other equation. Doing so, okay, when doing so, you'll get an equation in one variable only. Namely, by substituting, as you can see, what happens is we kill off the x, and we get an equation in only y. Only one variable. That makes it a lot easier. I mean, normally you would see x here. You think of x as a variable that you solve for. Here, we're going to solve for y now. So we do that now. 2 times 18 is 36. Oh, sorry, excuse me. We plug it in for x, as you can see. Right, I substituted. So we have 2 times 18 minus 2 times 4y minus 3y is 14. 2 times 18 is 36. 2 times 4y is 8y. Minus 3y is 14. Again, we're just trying to figure out what y is now. Once you plug it in, you have one variable to deal with. In this case, it's y. Let's figure out what that variable is. From here, we get 36 minus 11y is 14. That's what we get here. So again, we got x was 18 minus 4y, right? That was from the first equation. We plugged it into the second, actually over here. That's how we got this, as you can see. Then we, you know, just did some basic work, you know, distributing. We get 36 minus 11y is 14. Now we can solve this for y, right? Again, we wanted to kill off one of the variables, and we killed off x. Now we're left with y, and we can solve this. 36 minus 11y is 14. Subtract 36 from each side. We get minus 11y, right? The 36 is gone. We want to get y all alone. So we subtract 36 from each side. We get minus 11y is 14 minus 36, right? Subtract 36 from each side. We get minus 11y is minus 22. But we don't want minus 11y, we want y. So we divide by minus 11. The minus 11's cancel, we get y is 2. Y is 2. Now, are we done? Well, no, we're not done yet. And why is that? We have to get x, right? Remember, our solution is an ordered pair, right? The first number is what x is. The second number is what y is, in this case 2. So we have to figure out what x is. But can we do that? Well, yeah, we know what x is in terms of y, right? Taking y equal to 2 and using the equation for x in terms of y, we plug it in. We get x is 18 minus 4 times y, which is 18, minus 4 times 2, which is 18 minus 8, which is 10. So altogether, we get x is 10, y is 2. This is our ordered pair. That's a solution. The first number is x. The second number is y. That's what I was trying to say before. Okay, so we have substitution. And as a check, we can always graph it. I graphed this in Desmos. And you can see that, oh yeah, 10, 2 is on both of the graphs. It's a point of intersection. Hence, it's a solution to both equations. And that's what we get. Okay. Are there any questions on this example? Yeah, I really hope I didn't go too fast. I mean, I didn't want to get through, how do I say this? I am reviewing, so that's probably why. That's why I'm going a little faster than I normally would. But are there any questions at all? I want everyone to understand. Okay. All right, let's keep going then. Let me just